Welcome to CSEGuru. In this session, we will discuss the topic topological sorting. Topological sorting can be implemented with the help of two methods. One is DFS method, another one is source removal method. DFS method already we have discussed with example. So now we will discuss source removal method. So this topological sorting is a method based on decrease and confire technique. That is, it comes under the algorithmic design technique decrease and confire. Topological sorting is nothing but ordering of vertices along a horizontal line so that all directed edges go from left to right. So in this session, we will discuss source removal method. So the design steps for source removal method is, in the given graph, identify the vertex with no incoming edge. The particular vertex with integrity 0. So you need to identify the vertex in the given graph such that its integrity should be 0. Okay, and delete along with the outgoing edges. That particular vertex you need to delete along with its outgoing edges. Okay, if there are several vertices with no incoming edges, break the tie arbitrarily. Obviously, we will break the tie in alphabetical order. So alphabetical order, which vertex comes first, that we will take it first and remove first. Okay. So the order in which vertices are visited and deleted one by one results in topological sorting. Very simple logic. Identify the edge with integrity 0, remove it. One by one in the given graph, identify the edge with integrity 0 and remove it. Okay. And finally, the order of the deleted edges is nothing but the topological sorting. So now we will discuss with one example. So this is the given graph. So first thing we need to consider in this graph is check whether this graph forms a cycle. If this graph forms a cycle, in the sense topological sorting is not possible. Okay, that is a main constraint. So for any graph given, first you need to check whether it is having any cycle. See here, there is no cycle. The direction you have to consider, it should not form a cycle. So this graph does not form any cycle. So we will implement topological sorting. So first thing is, step 1, you need to identify the vertex with integrity 0. So here 1 also integrity 0, 2 also integrity 0. So what we will do? We will break the tie and remove the vertex 1. So if you are removing vertex 1 along with its outgoing edge, you have to remove. The vertex also you have to remove and the outgoing edge also you have to remove. So if you are removing in the sense, you will get the graph like this. So 1 you will remove and the remaining vertices and its edges, everything you have to include. Okay. So this is the graph you will get it after removing 1. Next, in this step, check the next vertex with integrity 0, which is nothing but vertex 2, integrity 0. So next step, remove the vertex 2. So if you are removing vertex 2 along with its outgoing edge, in the sense, the graph will be like this. 3, 4 and 5 only will be there along with its edges. Okay. Next step. Identify the next node with the integrity 0. That is nothing but vertex 3. So remove the vertex 3 along with its outgoing edges. Okay. So here if you are removing 3, you will get vertex 4 and 5. Okay. Next step. Identify the vertex with integrity 0. The next vertex with integrity 0. That is nothing but 4. Remove vertex 4 along with its outgoing edge. So next node with integrity 0 is 4 and remove 4. If you are removing 4, you will get vertex 5 only. And the next step, remove 5 also. Okay, so now the graph is empty. Okay, see now if you are ordering the vertices, if you are ordering the removed vertices, in the sense, you will get topological sorting. So topological sorting or otherwise topological sequence also they will tell it. Both is same only. So topological sorting is nothing but first we have removed vertex 1. Okay. And then we have removed vertex 2. And then we have removed vertex 3. And then we have removed vertex 4. And then we have removed vertex 5. So this is nothing but topological ordering of vertices. So this is nothing but topological sorting. And this is nothing but the ordering of vertices. So source removal method is nothing but in the given graph, first you have to check whether the graph forms a cycle. So if the graph forms a cycle, in the sense you cannot able to implement any method, even DFS method also not possible, source removal method also not possible. Okay, so first thing you have to check this constraint. So if the given graph does not form a cycle, in the sense we can implement topological sorting. So how we can implement, in the sense, step by step identify one vertex with in-degree 0. If more than one vertex is having in-degree 0, in the sense, you need to break the tie in alphabetical order. So alphabetical order, which vertex comes first, that you have to remove first. Okay, so identify the vertex with in-degree 0, remove that vertex along with its outgoing edge. Both you have to remove it. Okay, so in each step, identify one vertex with in-degree 0. If the graph does not form a cycle, in the sense, this is possible. If it forms a cycle, in the sense, you cannot able to sort it out. Okay, so every step identify the vertex with in-degree 0 and remove the vertex along with its outgoing edge. So step by step, if you are implementing, in the sense, finally the graph will be empty. Okay, so the order in which you have deleted the vertices, if you are implementing, in the sense, that is nothing but topological sorting. So topological sorting is simply ordering of vertices. So the source removal method is very simple logic. Thank you for watching this video.